Uh, Hi to all. In this video, we are going to see about design of stator and stator slots of a three-phase induction machine. The stator of an induction motor consists of stator core and stator slots. Okay, the stator slots mainly classify into three types. One is semi-closed, another is this one open type, another is taper type. Okay, now we come for that one. Status slots in general, two types of status slots are employed in induction motors via open slot and semi closed slots. The third one, we are not tapered type of slots we are not going to use in three-phase induction motors. Operating performance of the induction motors depends upon the shape of the slots, and hence it is important to select suitable slots for the stator slots. Open slot. Okay, this one is the open slot. In this type of slots, the slot opening will be equal to the uh, width of the slot. From this point to this point, the width will be equal. Open slot. Okay. Figure 10.1 figure 10, this one. In such type of slots, assembly and repair of windings are easy because here also wide, here also wide, so we can easily repair, and assembling also easy because we can wound the windings easily in this. Okay, next, okay. However, such slots will lead to higher air gap, but air gap will be more in this type of slots. Next one, semi-closed slots. In such type of slots, slot opening is much smaller than the width of the slot as shown in the figure. This one. This one is the semi-closed. Here the width will be high, but here that entering point, the width will be low. Okay. Hence, in this type of slots, assembly of windings is more difficult and takes more time compared to open slots, and hence it is costlier. However, the air gap characteristics are better compared to open type slots. Here, air gap losses will be there, but here in the semi-closed, um, air gap losses will be less. Tapered slots. In this type of slots, the opening will be much smaller than the slots width. However, the slot width will be varying from top of the slots to bottom of the slot with minimum width at the bottom as shown in the figure. This is the tapered one. But this type of slots we are not going to use in three-phase induction machines. Okay, semi-closed slots. See here in this point, that width of the slots will be very less, but here that width will be very high. Okay, so this will be the stator slot, and this will be the stator laminations. This will be the shaft. This will be the air gap between stator and rotor, and this will be the rotor laminations, and this will be the rotor slots. Okay, selection of number of slots. Number of stator slots must be properly selected at the design stage. As such, this number affects the weight, cost, and operating characteristics of the motor. Suppose if you go for more number of slots, then we have to wound more number of windings. Then the weight of the machine should be increased, like that. When we go for less number of slots, then the less number of windings needed, but that efficiency will reduce. So both the things we should take care. Okay, number of slots must be properly selected at the design stage. As such, this number of affects the weight, cost, and operating characteristics of the motor. Though there are no rules for selecting the number of stator slots, considering the advantage and disadvantage of selecting higher number of slots, comprise has to be set for selecting number of slots. Following are the advantage or the disadvantage of the selecting higher number of slots. Advantage: reduce leakage reactance. When you go for high value of slots, the leakage reactance will be reduced. At the same time, reduce tooth pulsation losses. Okay, when you go for high value of slots, pulsation losses will be less. Higher overload capacity, we can go for higher load in the case of high value of slots. Okay, disadvantage, increased cost. Cost will be increased because we have to work for number of slots and we should bound for the windings. So increased weight. When we go for more number of windings present there, the weight also will increase. Okay, and increased magnetizing current because of more conductors will be present. The magnetizing current also increased. Increased iron losses. Okay, and poor cooling because more conductors will be there. The cooling will be less. Increased temperature rise when that more conductors will be present, so the temperature rise also will be more. Because of these things, reduction in efficiency, the efficiency of the machine will be reduced. Based on the above comprise Based on the above comprise it made, and number of slots pole per phase may be selected as 3 or more for internal slot winding. However, for fractional slot windings, number of slots per pole per phase may be selected at 3.5. So, selected number of slots should satisfy the considerations of the stator slots which at the air gap surface, which should be 1.5 to 2.5 centimeter. Stator slot pitch at the air gap TSS is equal to pi d by SSS, where um, is the SS is the number of stator slot. Area of stator slot. Slot area is occupied by the conductors and the insulations, out of which almost more than 25% of the insulations. Once the number of conductors per slot is decided, approximately area of slot can be estimated. Slot space factor, copper area of the slot by area of each slot. This slot space factor so obtain will obtain 0.25 to zero point 0.4. The detailed dimensions of the slot stated as follows. Size of the slot. Okay, normally the different types of slots are employed for carrying stator windings of induction motors. Generally, full pitch double layer winding are employed for stator windings. For double layered windings, the conductor per slot will be even. These conductors are suitably arranged along the depth and width of the windings. Stator slots should not be too wide, leading to thin tooth wide. Okay, with which makes the tooth mechanically weak and maximum flux density may exceed the permissible limits. Hence, slot width should be selected such that flux density in the tooth between 1.6 to 1.8 Tesla. It should not go beyond the 1.6 to 1.8 Tesla. Further, the slot should not go too deep, and also otherwise the leakage reactance will increase. As a guidance from the ratio of slot depth to slot width may assume 3 to 5. Slot installations details along with the conductor shown in the figure. This one. Proper slot installations as per the voltage rating of the machines has to be provided before inserting the insulating coil in the slots. This slot installation is called slot liner. Slot liner, this one. Slot liner is a coil. Okay. And suitable thickness of the installations coil separated by two layers of coils. This one, coil separator. This one is a coil separator. Okay. Uh, Thickness of the coil separator is 0.5 mm to 0.7 mm for low voltage machines and 0.8 mm to 1.2 mm for high voltage machine. The thickness the coil separator should be 0.8 mm to 1.2 mm. Okay. Wedge of suitable thickness 3.5 mm to 5 mm is placed at the top of the slot to hold the coils in position. Lip of the slot taken 1 to 2 mm. Figure 13. This one shows the coil placed in the slots. Thank you.